All right, so let's finish the unit circle then. So we'll go back and talk about did you guys finish the bottom part for sine and cosine? Okay, it looks like Jenny did, Lauren did not. So let's just go back through it real quick so that we can do this so you understand still, okay, since we didn't quite finish it. So if I look at 7 pi over 6 here, okay, in the third quadrant, you'll notice that if I bring down this triangle that's at 5 pi over 6 was the same triangle we used over here at pi over 6. So I could take this segment down here. Right? There's my vertical distance. And then my horizontal distance would be the same distance here, which it was for 30 or pi over 6 and 150 and 5 pi over 6. So what that means then is that the horizontal distance is the same, the vertical distance is the same. The only thing that's different is then the fact that if we're in the third quadrant, that sine and cosine, or cosine and sine, are both negative. So that means that the same values I use at pi over 6, 5 pi over 6 are going to be the same, square root of 3 over 2, 1/2. For cosine and sine, the only difference is that x and y are both negative in those quadrants. That would be a 4 there. Put that 6 there. Okay. 5 pi over 4 then is the same as pi over 4, same as 3 pi over 4, 5 pi over 4. The coordinates are negative square root of 2, or square root of 2 and square root of 2, square root of 2 over 2 and square root of 2 over 2. It's just that then those are both negative. In the fourth quadrant then, is x positive or negative? Positive. And y is negative, so we have positive for x, negative for y. Now, 11, let's go to, we'll do the 5 pi over 3 first. 5 pi over 3 has the same y value here as pi over 3 had, and the same x value as pi over 3. So 5 pi over 3 is the same values as pi over 3. So we have 1/2 for x, square root of 3 over 2 for y. It's just that y is negative in the fourth quadrant. Seven pi over 4 has the same reference angle then as pi over 4. So square root of 2 over 2 for both of them, except y is once again negative. 11 pi over 6, same as pi over 6, square root of 3 over 2, 1/2, except the 1/2 is negative. So this whole thing is just a matter of reflections. If you know the first quadrant, we can reflect over to get the second quadrant, and then reflect down to get the third and fourth quadrants. All right? So there's sine and cosine. We need to look at tangent. All right, we'll go with this dark purple here. Okay, now for tangent then, if we look, tangent is the one on the outside, but we've defined, when we were looking at sine and cosine before, we were just talking about it on that one problem that Thomas asked about, that we know that cosine of theta is x over r. Sine of theta was y over r. And tangent of theta is y over x. So we can look at tangent a couple different ways. We can look at it as y over x, so taking all of our y values, dividing by our x values, or when we're on the specific triangles, using those numbers there. Okay. So let's go around the circle first of all. Okay. In the first quadrant, oh, I didn't write these down, that positive in the first quadrant for cosine and sine, x and y, negative and positive in the second quadrant. Now tangent though, if we take y and divide by x, what do we get? What is in the first quadrant? What's a positive divided by a positive? Positive. So tangent's positive in the first quadrant. What's a positive divided by a negative? Okay, so tangent is negative in the second quadrant. Okay, remember tangent's always going to be at 1 on the outside. Third quadrant, negative divided by a negative is a positive. And a negative divided by a positive is a negative in the fourth quadrant. So inside the parentheses, x and y is cosine and sine. Outside it's tangent. So let's do the axes first. Okay, just like we did when we did cosine and sine last week. So at 0, what's y divided by x there? What's 0 divided by 1? What's 0 divided by 1? 0. Okay, so this is 0. So tangent at 0, 360 and 2 pi is 0. What about at pi over 2 then? What's 1 divided by 0? Undefined. You cannot divide by 0. It's undefined. At pi, we have 0 divided by negative 1. So that's going to give us 0. And at 3 pi over 2, divided by 0 again, which means that's undefined. Now, the first quadrant then are 30, 45, and 60-degree angles. Now, you may have written those on your note card, or those are on that page 930, whatever it is. We had all those on there. Okay. Got your chemistry calculator going? All right, so 30 degrees tangent. At 30 degrees, it's opposite over adjacent. So 1 over the square root of 3, which is the square root of 3 over 3. At 45 degrees, opposite over adjacent, so 1 over 1, so that's 1. And at 60 degrees, square root of 3 over 1, square root of 3. And then we're going to use those same reflections to get the other 3 quadrants with tangent. It's just going to be a matter of whether the sign is positive or negative. 2 pi over 3, those are the same numbers as pi over 3. So this would be square root of 3, but tangent in the second quadrant is negative. 3 pi over 4 would be negative 1. And then 5 pi over 6 would be negative square root of 3 over 3. And once again, in the third quadrant, where most people make their mistake, where they get things flipped around. 7 pi over 6 is pi over 6 from the horizontal, or 30 degrees from the horizontal. So I have to use the same one here. So you have to think about it as that vertical reflection. So this is square root of 3 over 3 at 7 pi over 6. And many people get 7 pi over 6 and 4 pi over 3 mixed up with their angles or their points here for sine, cosine, and tangent. Be very careful of that. And then fourth quadrant, they're all negative. And there's your unit circle. Get some of this stuff in. So we'll sit there. All right. So what we're going to do now that we have the unit circle then to use, we're going to go ahead and show you how to use it and when are we using it for. And we're going to use it for lots of times where we have angles that match an angle on the unit circle. Then we can find sine, cosine, and tangent by knowing them. So here it is in without tangent on it. Okay, so we're going to do some evaluating. All right. So we're going to look at using the unit circle. So for the next couple days, you're going to want to make sure that the first thing you do when you get in here is get it out. Make sure you have it right in front of you. This is still section 3, lesson 13.3. So it says use the unit circle to find the exact value of each trigonometric function. Cosine of 225 degrees. So on your unit circle, look for 225 degrees first of all. Find that angle. So which quadrant is 225 in? Okay, in the third quadrant. All right, so we're going to go over to the third quadrant. All right, it's down here. Here's 225. It is right here's 225. All right, and cosine is the x coordinate for the point. So that would be this one right here. So the answer would be negative square root of 2 over 2. What's that? Mm-hmm. Yep. Yep. No, you're going to memorize. The reason that we're memorizing is because you need to be able to recall as easily as possible the ones there. Because, yes, so on Friday, I will give you a blank unit circle, just like the one I gave you the other day, and you will fill it out for me. And then you'll turn it in. And then you can pull that one out and use it for the rest of the quiz you'll be doing. Okay? All right. If you can memorize the first quadrant, you should be able to do all of it. Okay, it's all about reflections and like that. Everything. Okay, there's 5 parts there: degrees, radians, sine, cosine, and tangent. You got to remember all of them. Okay, tangent 5 pi over 6. So where is 5 pi over 6 at on the unit circle? Which quadrant? Okay, it's in the second quadrant, right? All right. So 5 pi over 6 is right here. And we're looking for tangent, so that would be the one on the outside. So that would be negative square root of 3 over 3. Now, here it talks about the quadrants here, and we already did this. Okay, we put that on our unit circle. They talked about the signs of positive and negative in there, and we're aware of that, so that's not a problem. Now, in example 3, they say use reference angles to evaluate these, and there's really no reason to do that. Okay, I wouldn't worry about the reference angles. My first question is this, though. Okay, what is the reference angle for 330 degrees? Okay, what is it? 30 degrees. How do you know it's 30 degrees? Okay, it's 30 degrees from 360. Okay, that, oh, it's right here. Here's 330, right here. Okay, and that's 30 degrees from 360 degrees. So that's the reference angle. So basically what they're saying here is I could use the 30-degree reference angle to find all that information, just a matter of changing the signs then. But what I would do is I would go right to my unit circle, and they want to know what cosine, sine, and tangent are. And so I go to 330, and I have them written right there. So it says find these. Then the only thing is I'm looking for is to make sure that you write it correctly of what you're supposed to write down. And so we will say the cosine of 330 is equal to square root of 3 over 2. The sine of 330 is equal to negative 1/2. And the tangent of 330 is equal to negative square root of 3 over 3. So when they ask you for those, then you need to make sure that you are writing them out just like this. Don't just write down those 3 numbers and assume I know what you're talking about. You have to be specific. Cosine equals this. Cosine of the 330 equals this. Tangent of 330 equals this. It's basically an exercise. Can you find the stuff on unit circle? If you can, then you're doing good. Okay, I have one more example to look at. All right, here's an application. Bring us back to our application problems. All right, and talking about radians again. Okay. We're going to talk about something called arc length. Okay. Well, arc length, all that is radian measure. Okay. How far around the circle are we going? Okay. For a circle of radius r, the arc length s, intercepted by a central angle theta, which is measured in radians, is given by the following formula. So to find the arc length, we multiply radius times the measure of the angle in radians. Now, that should make sense to you because we are actually talking about a part of the circumference. Because when we were talking about this the other day, circumference is the distance around the outside, right? And which is, the formula for that is 2 pi r is circumference. But if I have a radius of 1, it's just 2 pi, right? Which is the distance around the unit circle. So to find arc length, all we're going to do is multiply the radius of the circle times whatever our angle is in radians, because that's only part of the way around, okay, unless we've gone all the way. Okay? Right. And then we talk about revolution, so this kind of goes a little different direction, but let's look at this problem. It says a tire of a car makes 653 complete rotations in 1 minute. The diameter of the tire is 0.65 meters. To the nearest meter, how far does the car travel in 1 second? So what we need to do is we are finding arc length. We've got to find out how far around it goes. Okay. So we've got a couple different options here for starting this problem. We can change our time from minutes to seconds right away, okay? Or we can find our distance right away. Either one. Okay? Which one would you rather do? Okay, time. All right, so it says it makes 653 complete rotations in 1 minute. If it makes 653 in a minute, how many does it make in 1 second? Okay, so if I take 653 and divide by 60 or multiply by 60? Does it do 60 times more per minute, or 60 times less per minute, or per second? Okay. Okay. In 1 second, does it do more rotations or less? No. If it does 653 rotations in 1 minute, does it do fewer than that in 1 second or more than that in 1 second? Fewer, right? Because 1 second is less time, so it's not going to do it as much, so I need to divide by 60. Funny how sometimes those simplest things we have to think the hardest to get. You just have to think your way through them. All right, so what's 653 divided by 60? 10.1? No, 10.9, okay. All right, so we have 10.9. This is how many rotations it makes in 1 second, okay? All right. Says the diameter of the tire is 0.65 meters. To the nearest meter, how far does the car travel in 1 second? So what we want to find is we want to find the arc length. We want to find how far around does it go. So we need to multiply to find this length. We need to multiply the radius of the car times the angle that it travels. Well, it tells us 10.9 rotations. Is that an angle? It is? Okay, so I should put 10.9 here for theta? Okay, all right. How much is one rotation? Remember, one rotation means I went, here's one rotation right there. How far did I go? 360 degrees, but we're talking about radians, so it would be, how far is all the way around the circle in radians? All the way around the circle in radians is 2 pi, okay? 2 pi. So my angle then, theta, is going to be 10.9 times 2 pi. R is the radius, and they tell us that the diameter is 0.65 meters, which that makes the radius equal to what? How's the radius compared to the diameter? Is it twice as far, or is it half as far? Half, okay. So this is 0.325, right? So to find how far the car traveled in 1 second, we're going to multiply 0.325 times, what was 10.9 times 2 pi? 21.8 pi, right? Right. So how many meters is that? you can use the pi button on your calculator. .3 meters, or in this case they want to the nearest meter, so approximately 22 meters. So we had to find how far did it go in angles, okay, in a measure of an angle measure. So that's what the theta is. How far did it travel in, as far as angle measure? It went 10.9 rotations in 1 second. So that means it went 21.8 pi around the circle. Okay? And then times the radius of 0.325, and that told us how far it travels in 1 second, approximately 22 meters. Is that how far you would travel in a second? About?